Hey guys, welcome back to our Learning Unreal Engine tutorial series. In today's video, we're going to take a preliminary look at blueprints. We'll start off by talking about the concept of blueprints. What are they? Why are they important? What kinds of things can we use them for? Then we'll walk through the blueprint editor briefly and talk about how they function. And we'll wrap up the video by creating a couple basic blueprint objects to play with in our project. So let's go ahead and get into it. Before we really dig too deep into the system itself, I just want to take a couple minutes to get on the same page about what a blueprint is. The Unreal Engine documentation defines the blueprint visual scripting system as a complete gameplay scripting system based on the concept of using a node-based interface to create gameplay elements from within Unreal Editor. As with many common scripting languages, it is used to define object-oriented classes or objects in the engine. Broadly speaking, a blueprint is a container for visual code that defines an object, including what it does, what happens to it, how does it interact with other objects, and so forth. A blueprint can contain multiple components, including art assets like meshes and materials and particle systems, lights, hidden components, variables, object references, visual code defining gameplay logic, functions and macros, and communications with other blueprints. So why are blueprints important? Well, they allow us for quick prototyping, they give us functionality for visually debugging, they make the code more accessible to artists and designers, and they act as a common system for many different modules within Unreal Editor. For instance, you have a character blueprint here, which is more of a standard blueprint class. You also have things like animation blueprints, and even blueprints for game modes or specific levels, like the level blueprint here for the third-person map. The user interface editor and the material editor also use similar functionality. Blueprints, as mentioned, can be used for things like levels and gameplay modes, or characters, either playable characters, non-playable characters, enemies. They can be used to create vehicles, weapons, collectible objects like currency and power-ups, or interactive objects like doors, elevators, or light switches. So let's go ahead and take a look at the blueprint editor. In order to do that, we will examine the third-person character blueprint, which is the main character for our current project. We'll start off by clicking over into the tab for the viewport. And here you can see all the visual aspects of our character, as well as some that will not show up in the game. So here's the character mesh. And just like in the viewport of the editor, we can move this around, rotate it, or scale it. We also have a capsule collision component, an arrow component, and a camera component, which is attached to a camera boom that is hidden. You'll notice that as I'm highlighting these things, they should also get highlighted in the components window on the left, or the components panel. And you'll see that we have one more component here for character movement. As we switch between these, the details panel on the right side switches to context-sensitive details about whatever component we are working with. Below the components panel, we have the My Blueprint panel, which contains references to pretty much everything within the blueprint code itself. So we have our event graph, as well as other events that exist within that. We have functions, which currently contains only the construction script. We have macros that are currently empty, variables, and event dispatchers. We'll talk more about variables later. But for now, let's go ahead and look at the construction script. The construction script for this blueprint is currently empty, and we won't be working with that too much today. But it's worth noting that the construction script is what code gets called on when you first fire up the game or an object is first instantiated into your game. Tabbing over to the event graph is where we'll spend most of our time when building up a blueprint. Here's where you define all of the core logic for how things work within the game. Just taking a quick look at the character blueprint, we have comment boxes for what everything is doing. We have input mapping, camera input, movement input, and jump input. As you can see, I can zoom in and out with the scroll wheel. I can right click and drag to move around. I can left click and drag to highlight multiple nodes. Finishing out our quick tour of the blueprint editor, up at the top, you can see that we have the standard menu bar, as well as a toolbar here for common tools. Your save button is here, as well as your compile button. And compile will just check your blueprint for any errors and make sure that it's good to go. If I hit that, it looks good to go. We also have class settings, which are some basic settings for this blueprint class, as well as class defaults, which basically is the details panel for the class itself. We can also run simulations from here, but we typically will do that within the editor viewport. And lastly, we can select a debug object. So if we have one specific object in our level that we want to watch while debugging, we can select that here. Taking a quick look at variables, if we want to add a variable to our blueprint class, simple as adding using the plus button beside variables. Let's go ahead and add a variable. We'll call this current health. I can rename it there, or I can rename it in the details panel here. But you'll see that we can't give it a default value until we compile. And then we can change its default value. Currently, it is set as a Boolean type variable, which just means it's a yes or no, true, false. And that's not what we want. So either here in the dropdown in the details panel, or here in the dropdown in the variables group, I can select what type of variable I want this to be. All of your most common types are listed here at the top. We have booleans, bytes, integers, 64-bit integers, floats or decimal points, names, strings, texts, vectors, rotators, and transforms. You also have a bunch of structures, which are groupings of different types of variables all in one concise structure. We have interfaces, which we'll talk about in a future video. Object types, we can get a reference to basically any type of object within our project. All the way up the hierarchy to actor, or all the way down to something as specific as, oh, I don't know, our animation composite or animation blueprint. And lastly, we have enumerator types. We won't be using any enumerators today, so we will ignore that for now. We want current health to be a float, so we'll just go ahead and change that to float. You'll see it does not update in the details panel for our default value, so we'll need to compile, and then we can come back and give it a default value of something like 100. Before we start making anything, I want to go ahead and talk about a few blueprint best practices. First, you should only put things into a blueprint that belong in that blueprint. For example, the character blueprint should only contain things that directly pertain to the character itself. You should always try to reuse the same code as much as possible where it makes sense. Functions and macros are your friend for this, but don't overdo it. To those first 2 points, also, consider creating a child blueprint class if you need to extend the behavior of a base class for specific instances. You should always try to minimize how much you use the level blueprint, since that's not as reusable as putting your gameplay logic in a different blueprint, like a character blueprint, or a scoreboard actor for keeping score, or better yet, in the game mode itself. These things can more easily be reused on other levels, they're easier to make changes to down the road, and they're easier to interact with than the level blueprint. Another tip is to try to avoid doing work on tick as much as possible. Tick events and similar operations fire on every frame. Not only is this potentially resource intensive, but it can also create inconsistent gameplay on different machines, platforms, devices that have different frame rates. Minimize using casts to communicate between blueprint actors. Blueprint interfaces are a more sturdy and flexible form of communication and can replace many casts. You can still cast if you need to for the actual purpose of casting, which is verifying what kind of object is doing a thing. We'll get more into casting later. Naming conventions make a huge difference. Make sure you're on the same page as the rest of your team for that. And finally, if you're an artist or designer and a blueprint is getting too big, thinking like hundreds of nodes, then maybe talk to a programmer. Make sure you're doing things right and up to the coding standards of your team. See if you should be creating a child class to take some of that logic off of the main class, or perhaps even moving some of the code into C++. Most blueprints should be limited to only the code necessary for that object to function. So with that, let's go ahead and start making a couple very simple blueprint actors. I'm going to close my character blueprint for now. Well, first I'll compile and save. Make sure we save our changes. And I'll close that. And we can come into our level. Here in my blueprint examples folder, I'm going to right click and create a new blueprint class. Here you can see the common types of blueprints that you'll be working with most of the time, or we can come get a very specific type of blueprint from our library of all classes. For now, we're going to stick with actor, which is an object that can be placed or spawned into the world. And we'll call this BP underscore hello world. I'm going to drag a copy into our level so we can see it as we're building it up. And just make sure that the placement is appropriate for what we want. I'm going to go ahead and double click to open that up. And you can see we start off in the viewport with a blank blueprint. The first thing I want to add is a way for us to interact with this. The way I imagine this working is that as we walk into some volume, some space, then it will do something. It will tell us, it will say, hello world. So I need a collision volume of some sort. If I type in collision here in the components panel, after hitting the add button, of course, you can see that I get 3 different types of collision: box, capsule, and sphere. Any of these could work, but I think we want to start off with a box. We'll go ahead and rename that right off the bat to collision box. And we'll make it a little bit bigger so that, as you can see in the world, this doesn't start off very big. And we need some space to walk into. I'm thinking maybe something like 200. That around so we can see everything while we're making changes. So I'm making a change here in the detail panel to the box extent. I'm making it 200 by 300. Maybe we'll just go ahead and double the Z value to 64. Give us a little more height. Now you can see I'm only getting about half the height here. Some of it is underneath our level. I'm just going to grab that and bump that up a little bit here until it's pretty close to flush with our floor. Now, when we walk into this box, we want to do something. So I'm going to come into our event graph. I'm going to go ahead and delete all of these base events that come with it and drag in my collision box. As I drag that in, you see in the details panel that I get some events that interact with the collision box. I'm going to go ahead and hit the plus next to begin overlap, because we want to do something when the box is overlapped. Here you can see on component begin overlap collision box. So this does not actually need our reference anymore. You can delete that. And we have our event. Up top is our execution pen, which will tell us to do something else when this is called upon. We have a reference to what component is overlapping, what actor has overlapped, other components, other body indexes, from sweep, and sweep result. We won't worry about these bottom ones too much. We'll start off with just working on our execution pen. So just to test out that our collision is working, I'm going to print a string. As you can see, this is for development only. This will not be something that is in our final game. And for the string, I'll just have it say hello world. Give it a color. Go with a bright pink. And we'll extend the duration just to make sure we have plenty of time to see it, up to 5 seconds. So anytime anything overlaps with our collision box, it should print a string to our log that we can see in the level. Let's go ahead and test that out. If I walk into that area, you can see in the top left, it says hello world. Every time that I enter, it will add one to stack there. And after 5 seconds, they start to just. That's working pretty well. We know that the collision is working. But we don't need that for now. I'm going to alt click, disconnect that, and pull it off to the side in case we need it later. Instead of printing to the log, I'd much rather have it display something in the world itself. Let's come in here and add another component. And here we will add a text render. We will call this hello. In the details panel, we can change what that text is. I would say hello world. We can change the alignment of our text. I'm going to go ahead and center it both vertically and horizontally. I know that white is going to be kind of difficult to see against some of our backdrop, so I'm going to go ahead and change the text render color. We'll go with pink again. The X scale, Y scale, world size, all of that should be fine. I still kind of want to change that color a little bit more. That should be good for now. I'm going to compile and save and see what it looks like. We can tell right away, A, it's backwards. We need to rotate our actor around. Do that here. It's sunken into the 0 of our actor, so we need to move that up a bit. I just grab my text in the viewport, and I can scoot it up. And also kind of just want to rotate it just a little bit to give it some variation. Now, if I come in and play, it will always just say hello world there. That's because we haven't actually hooked up any code to change that. So let's back out, back in. When we start play, we don't want it to be showing. So here in the details panel, we can just turn off the visibility. And that'll take care of that issue. Next, we need to add some logic to our begin overlap. So when we overlap, we want to affect our hello text component. And we want to change the visibility. If I type in change visibility, nothing comes up. But if I just type in visibility, you can see I get toggle or set visibility. Technically, we could use either, but it's a little bit more consistent and reliable to use the set visibility here. And we'll just turn the new visibility to true and hook up our execution pin. Compile, save, and we can go test it out. One thing I want to do while we're testing it out is I want to show you how you can watch the code itself to help debug any issues that come up. So if I go ahead and hit play, and keep an eye on that execution pin in the bottom right as I walk in, and you can see the execution firing. If I leave, come back in, leave, come back in. It's firing multiple times, but it's always just setting the visibility to true. We're never actually turning the visibility back off when we leave. Well, that's simple enough to do. All we need is another event for our collision box on end overlap. And do the same thing as we did here. Set the visibility. On Control C, Control V to get another set visibility. Hook up our execution pin. Target the hello text. Turn visibility off. File, save. And if we play, the text should now turn itself on and off when we enter and leave. Okay, so that all seems to be working. What if we want to add just a little more flair to it and make it bob up and down in place, our text object? Well, we can come in and we can add one more component, and we want to give it some movement. I'll just type in movement, and we get some different movement component options. We don't want it to rotate. We don't want it to be a projectile. And floating pawn might be able to work. This isn't really a pawn class, so let's just go ahead and use interp to move. And we'll call this vertical. I hit compile. Now I can come over here into my details panel. And I can add some control points We're going to start off at 0, 0, 0 relative to our object, and we'll go up and down in the air, let's say maybe 65 units on the Z. We don't want it to teleport. We don't just want it to one shot, we want it to keep going. So let's use a ping pong behavior type. And let's go ahead and see what that looks like. And there you can see our text is now moving up and down in the world. There are obviously other ways to handle movement that might be better or worse for your particular use case. You might want to actually animate it somehow, or you might want to use a timeline. But for this simple up-down movement, this is about as good as it gets. And if I leave, turn off. And if I enter, turn back on. I think that should suffice for our hello world object. Let's go ahead and create one more simple overlapping type of blueprint class. It'll do something when we overlap it. We'll also make it an actor, and we'll call it BP. I'm going to drag a copy of that into the world here. And instead of double clicking, you can also hit Control E to open up that class when you have it selected. For this, I know I'm going to need some sort of collision. And we'll do a sphere this time. We'll call it collision sphere. I also know that I need a light of some kind. So we'll type in light, and we will use, really we could use either point light or spotlight. I think we'll do point light for now. It's the simplest. And just to check what it looks like, currently our light is down on the ground. I want to move that up just a bit. And you can see as we change it in our viewport, it updates in the world. You can also see our collision sphere down here is pretty small. We would have to hit a really small target to interact with it. I'm just going to grab our collision sphere in the object and change our radius. I don't know what radius I want to use, so I can just drag to the right and slowly increase it until it fills about the space that I want it. I do want to go ahead and center that up in that square. And we'll make that an even 96 unit radius. File and save. So, just like we did with our hello world, we'll go ahead and delete our events, grab our collision sphere, and add events for beginning and ending overlap. I'll drag in a reference to our point light. We want to set ability to either true or false based on if we're entering or leaving. When we enter, we'll make that true. When we exit, we'll make it false. So we have the same basic setup as our hello world. Go ahead and compile, save, and let's test it out. Well, that's not good. If I tab out, I can come here and see what's happening. And I've actually got it setting visibility to true both when I enter and exit. Let's go ahead and fix that. And while we're at it, we'll do the same thing we did with the hello world text and just turn our visibility off by default so that it starts off as not showing. Let's test again. And that seems to be working. I do want to modify that a little bit. I think when we leave, it should stay on for, let's say, 2 seconds. And then turn off. I'm going to create some space here. And here between these two execution pins, I want to drag out, and I want to add a delay. The delay defaults to 2 seconds, or to 0.2 seconds, and we'll just change that to 2.0. Let's test that out again. And now when I leave this area, it should wait. 1, 2, off. 1, 2, off. That seems to be working. But what if I don't want, let's say I have multiples of these in my world, and I don't want them all to be on the same exact delay. I'm going to drag out some copies just using Alt-click and drag. Place some of these in my world. Don't have to be perfect, but I'd like them to be at least somewhat spaced out. There we go, got them all in place. And like I said, what if I want these to all go off on different delays? Well, what I can do is I can come into my blueprint. I can take this delay duration and right click, promote that to a variable. We'll call this delay off duration. Float type is perfectly fine. That's exactly what we need. If I compile, you can see the default is what was set in the delay originally at 2.0 seconds. I'm going to click on this little icon here to make the variable public and editable per instance. I'm going to go ahead and compile and save. And when I come in here now in the details panel in the editor itself, I now have access to my off delay duration and can change that to whatever I like. So as I run through these, they should all turn off on different durations now. Perfect. Finally, I don't want these all just to be white lights. I kind of want some multicolor in this. So we'll do that in our construction script. So that every time the light is instantiated, we can go ahead and set its color. I'm going to drag out a reference to my point light. Come in here and hit set color. Set light color is what we want. Plug that up. And I could come in here and make this a custom color or even a random color using RGB values by splitting my struct bin, or even doing a make color node plugged into that new light color. I don't want to do that though. I want to make these each editable on each one so that we know what color each one will be, but we can change them on the fly. I'm going to right click, and just like we did with duration, we'll promote that to a variable and call it light color, which creates a linear color variable, which by default will be set to white. I do want to make sure that my alpha value here is 1, although I don't know that that matters a lot. And then one other thing that I've noticed here is that this attenuation radius, so how far the light will reach, is really far and probably much further than we need. That's this big pale blue sphere. I'm just going to come in, grab my point light here on the attenuation radius, drop that down to something like 300. That should still be enough to affect the local area, but not stretch all the way out into the world and have a bunch of overlapping lights. These will still overlap to some extent though. I also kind of want to bring this down just in maybe 10, 20 units. That's personal feel for what I want. Okay, so let's go back to our construction script. When we instantiate the object, we will grab our point light component and give it a light color, defaulting to white. However, if we make that a public variable, compile, save, we should now have access to it on each individual light. So here I have light color. I like our hot pink theme, so we'll start off with a hot pink. The next one, maybe make it something light blue. For the next one, maybe an orange. The next one, something purplish. The next one up, we'll do a green. Sort of a teal green, maybe. Sea green. For this one, we'll go with a red. And finally, bright yellow. I'll go ahead and hit play, and let's see what happens. Pink, blue, orange, purple, green, red, and yellow. And they'll turn back on as I walk back through them again. Hello world is still working, still bobbing up and down, and all of our lights continue to work perfectly fine. We've been working for a while, so I'm going to go ahead and hit File, Save All. And that's actually where we're going to end this video for today. In future videos, we may come in and iterate on these objects or create more advanced objects to highlight different functionality of blueprints and grow our understanding to a more intermediate and then eventually advanced level of using blueprints. Please make sure to like, subscribe, and hit the bell. In our next video, we'll be talking about blueprint communications, or how we send information from one blueprint to another. Keep an eye out for that next week, as well as dev streams this week on Tuesday and Saturday. And as always, thanks for stopping by. We'll see you again soon.